Hey everybody. All right, so let's talk about these horizontal asymptotes. For rational functions, horizontal asymptotes and end behavior are synonymous. Okay? The horizontal asymptotes are the end behavior. So the line y equals k is called a horizontal asymptote of the graph if the function is approaching a certain number as x goes to the very ends of the graph, the end behavior. So as x goes to infinity or negative infinity, so the beginning and the end of the graph is f of x approaching a certain number. That's the end behavior, okay? So a lot of people think an asymptote is a number that you get really close to but you never hit. That's not true with horizontal asymptotes, okay? For a vertical asymptote, that is absolutely true. You cannot touch a vertical asymptote. But for a horizontal asymptote, let's just say there's a horizontal asymptote right here, okay? This is end behavior we're talking about. As we get really close to positive infinity and close to negative infinity, that's way out on the outskirts of my graph here. What happens in the middle of the graph doesn't matter. So this graph could be approaching, so as I'm going this way, it's approaching this line, but it's never really getting to it. But then in the middle, it could have crossed that line many times, okay? And even more so, there are some functions out there that have horizontal asymptotes, and as we go to positive infinity or something, we're actually getting really close to the line, but we're oscillating on either side of it. I mean, you would have to incorporate some trig into this rational function for that to happen. But it does happen. There are certain instances where you're actually crossing the horizontal asymptote infinitely many times. So don't think that we can't cross it. It's just a guideline as we go to infinity. We're eventually going to become that line. It's going to look like we're becoming that line. We don't actually ever get to that value. But so what I would really like you to do is to look at to take out your calculator and to put these three equations into your calculator to determine the end behavior. And so even though this has been a very short video, I'm going to pick this up on my computer so that I can show you what these look like on the computer, and then we can come to a consensus about how end behavior works, looking at the degree of the numerator and denominator. And if you go ahead, like on the notes that are provided, you'll see the answer. But I want to go through this exercise so that we can see it all together. So in the next video, I'm going to be on the computer, and I'll have my calculator out so that you can see how to put these into your calculator and hopefully discover how end behavior works for